process is the same for number 9. You just keep the inequality symbol, all right? So 25 raised to the 2x plus 40 greater than 125 raised to the 8x. What base do y'all think we should use for these? 5. All right. So 25 I'm going to change to 5 squared. And I'm going to keep the 2x plus 40. Right now, it's going to stay up there. Greater than 125 would be 5 cubed. And then that's going to be raised to the 8x. All right. Here's where y'all have to be careful. This power to a power. When you have the 2 terms up here, you need to make sure that you multiply each term. Right? Distribute. So you'd have 5 to the 4x plus 80 greater than 5, and up here I would have 3 raised to 8x would be 24x. I think I said that funny. All right. Yeah, now we're going to put, since the bases are the same, we're going to write 4x plus 80 greater than 24x. We want to work on getting x by itself, so I'm going to zero out this 4x over here. That gives me 80 greater than 20x. I'm going to divide by 20. And I would have 4 greater than x. Now that's an answer. But normally we would write our answer with x on the other side. So I want you to know you may end up seeing an answer that looks like this. X less than 4. So I didn't switch the symbol because I divided by a negative or anything like that. I just rewrote it so that the inequality had the x on the left side. These are the same. Any questions about that page? Move it on. All right. Number 10 says Mandy bought a computer system for $4,995. It's expected to depreciate at a rate of 11.5% per year. What will be the value of her computer system in 3 years? Round your answer to the nearest dollar. All right. So there's that word like depreciate. So this is one of the decays. So I'm going to write A of t. I want the amount after a certain time period. Remember, it's A sub O, your original, times 1 minus, for decay, not decay, the rate raised to the t. All right, I don't know the amount after a certain time period. That's what we're looking for. So that can stay. But what's the initial amount? What do we buy this for? And then this would be 1 minus our rate that it's decaying is 0.115. And then what was the time period? 3. So our t up there will be a 3. Can y'all see that? No. Did I get about 3,462? Make sure we're all about the same. It told me I could round to the nearest dollar, so we won't worry with the decimal.
I'm telling you.
On 11. Sketch the graph of the given function, then state the function's domain and range. Sketching should not be a big deal for you guys because you just put this in your calculator. Alright? So let's put this in y equals. What about the equation made it go this direction? The negative's good. Alright. Let's just get a couple of points just so our sketch looks kind of decent, okay? Y'all can tell it comes in over here next to the x-axis. An easy point to find on your table would be at the y axis, which would be 0. So do y'all see at 0 it says negative 2.3? And then we might as well go 1 is negative 4.6. Maybe at 2 we could go to negative 9.2. So there's a couple of points. Just put a few on there. And then y'all are going to do the best you can to kind of sketch it coming in next to the x-axis and then dropping off. Hitting those points. Okay, that's not what's difficult about this problem. Y'all got to make sure you tell me the domain and the range. The domain is the x's. So y'all look at that graph. I come in and I get the negatives, I hit 0, and I keep going. It's going to take it a long time before it spreads out, like a long time. But it will spread out. All right? So it is all reals. The range, though, when you look at this graph, do y'all notice how there are no positive values? I know, so I don't want to put any positives. There's no positive y values. Is it touching 0? It's not touching 0. So we want to say y less than 0. That was right.
Would it be equal to or no?
No, because it doesn't touch that axis. Remember, that's an asymptote right there. So if you put equals, you would tell me it touched it. And no touching on that. Everybody good? All right. And so we've been going, and you're like, this isn't as long as she said. And then we come to these problems. So take a deep breath. 12 is a long one. Y'all ready? I've warned you. That's all I can say. On 12, it says the percent concentration of a poisonous gas in a room is at 55%. An exhaust system is being used to clear the poisonous gas. The exhaust system fans are decreasing the concentration exponentially by 5% each hour. The area cannot be entered when the concentration is above 10%. So if it's 10.1, don't go in. If it's 10%, you're safe. Y'all got me? If it's above 10, you cannot go in there. Once it hits 10%, you're good to go. All right. Now, it says determine an inequality that could be used to express the number of hours T for which the room is safe to enter. All right. We'll check on that answer here in a minute. Do y'all notice that it says it is decreasing exponentially? So we're going to go A of T. This is kind of the general form so that y'all know. We have an initial amount, and then it's 1 minus R raised to the T. So that's kind of the generic formula that we're trying to fill in. What was the initial concentration of that gas? 55%. All right. So I'm going to go 0.55, 55%. If it's decreasing, it's going to be 1 minus. I'd written that up there. Okay, what's the rate that it's decreasing? What's it? 0.05. It's decreasing at 5%, so we would change it to 0.05.
We're ready for our third group of seniors, Kennedy Hayes through April Marshall.
Okay, so we're going to end up looking for the time. We're going to want to know what that time would be. Now let's talk about that 10%. Remember that 10%, when it gets below that, equal to that number or below it, it's safe to enter. Right now it's at 55%. So I want to go less than or equal to. I don't think it's 9. But we'll see. No. So does everybody have this inequality written? All right, y'all know where all the numbers come from. I'm not trying to be tricky on your test. The test is not this problem, but it is a poisonous gas that needs to decay. I mean, it's set up like this. Different numbers. Different numbers. Not trying to hide anything from y'all. All right, so everybody's okay so far? We're going to go down here and sketch the graph of the inequality. So what I want y'all to do in y sub 1, I want you to put the left side of this. You're going to go 0.55 and then parentheses 1 minus 0.05. Of course, raised to the x is what you'll have to put in. You can't put a t in there. And then y sub 2, you're going to put in 0.10 or 0.1. I'm going to show y'all on my screen what the regular window looks like. Kind of see how it's all squunched up down there on the x-axis? So it's hard to tell what's going on, so we're going to change our window a little bit. So go to window, please.
Will you give us the window?
Yeah, I think I will tomorrow. I'll help y'all. I'll put a window on the side. Or I'll probably put it up here on the board for you. That's a good question. On our window, let's change the x minimum. Let's go -1, just so you can kind of see where the axis is. The maximum I'm going to change to 50. The y minimum, I'm going to go 0. The maximum, I'm going to have at 1. And I'm going to have that count by 0.1. So change your y scale to 0.1. Now let's look at this graph. Hopefully it looks a little bit more like an exponential. Can you see how it's a little curved now? You can kind of zoom in there and see the curve a little bit.
Y scale up?
I changed it to 0.1. 0.1. Elijah, did you get this picture?
See.
All right. Now we want to sketch that. So let's sketch this drawing right here. Of course, this straight line, that's the 10%. So when your curve is above that 10%, that straight line, you can't go in that room. It's not safe. All right. But here's what we're drawing. This curve comes in, that gas is decreasing, but then it hits that point, and from this point forward, I'm okay. I could enter because it gets below that line. Right, how do I find this point?
Second intersection.
Yeah, second trace is the button, and then it is the intersection. So second trace 5, enter. So 33.2, and y'all notice the y value over there is at 0.1. All right, so the answer to this are the x values that work. So look what I shaded. I said, like, I'm not good. I can't enter the room until right here. And then once I hit this point, then down here I'm safe. Do y'all see how I'm shading to the right? All right. So my answer is going to be x greater than or equal to. It's greater than or equal to because we're going to the right. Those x values are getting bigger. All right? The y values are getting smaller, but the x's are getting bigger. So x greater than or equal to 33.2. That's how long it would take. So about a little over 33 hours. Now if you want your table to back up your answer, I need you to go down to your table down here, second graph. And we need the values around 33.2. So we're going to go 31, 32, 33, 34, 35. I scrolled earlier. I'm not going to scroll this time. I haven't started. All right. So do y'all see at 31 where mine says 0.11215? I'm going to write that over here. And same thing for the other values. All right, so look right here. At 33, you're not safe to enter. Isn't that above 10%? But at 34, it drops down. So between 33 and 34, I'm good to go. And that's what we're saying.